See, this is the example for the Kirchhoff's second law. So Kirchhoff's second law for the example, we take this as circuit. What is taken by this is a closed circuit. In a closed circuit, we are considering the positive and negative terminal of battery of EMF, and the three resistors R1, R2, R3 are connected in series. So which other direction is there? Is connected in a series. Now in series combination, there is no current of the variation. The same amount of the current can be passing through it. Now in this one, we have developed the sign convention. See, observing the sign convention. What is the sign convention? When the current and resistance having same direction, the current and the resistance and the loop is the same direction is taken by the minus. Now here the current how much is there? Because of here the potential dropped, here the potential dropped, here the potential dropped. See, the R1 resistance, we have the potential drop is V1, plus the R2 resistance, the potential drop is V2, plus R3 is there the V3, and we can observe here the current can be pass negative terminal to positive terminal. That means the potential gained. The potential gain means what is taken as plus E is equal to 0. From Ohm's law, V is equal to what we can have from Ohm's law. V is equal to how much is there here? I into R. But I into R, the current into resistance, current into resistance, current into resistance. But we can observe in this one the same amount of the current. And the loop and the current having the same direction we taken by the negative. So V1 is equal to minus I into R1. Here the minus I into R2 minus I into R3 plus E is equal to 0. See, why are taken the minus? The current and the loop is always taken a clockwise direction. The current is also the passing in the same direction. That time we take the minus. The ohms, what is the V is equal to I into R, but we take the minus. Plus into minus, minus, plus into minus, minus. Now in this one, the minus will be take the common. R1 plus R2 plus R3 plus E is equal to 0. Now this total term is taken this side. Then the E is equal to I into R1 plus R2 plus R3. Then write the current. In circuit, the current I is equal to, what you can the current I is equal to E by R1 plus R2 plus R3. See, this is the formula to measuring of in difficult circuits. The current I is equal to how much is it? E by R1 plus R2 plus R3. See, this is the using this type of we can using the find the current. And now we can using the Kirchhoff first law and Kirchhoff second law. We can develop in a Wheatstone bridge. So Wheatstone bridge is nothing but a comparing of resistance. Now we are discussing about the Wheatstone bridge. Now it is the continuation. Okay, the Kirchhoff first law and second law. After that we can derive the Wheatstone bridge. This is given by the total is the 8 marks. See, now we are discussing about the Wheatstone bridge. So Wheatstone bridge is before. A resistance can be measured by Ohm's law. Already we say the resistance can be measured by the Ohm's law. The using voltmeter and an ammeter in an electrical circuits. So using of Ohm's law, we can measuring of the resistance by using of a voltmeter and ammeter also. But this measurement is not accurate. To measure more accurately, that means the resistance can be compared. Who are the scientists? The first is the greatest site. The greatest site can be develop the one device, that is a Wheatstone bridge. What is the Wheatstone bridge? In Wheatstone bridge, we can comparing of 4 resistance. How many resistance can comparing by either? The 4 resistance are comparing by the that 4 resistance we are considering by the PQRS. Now see, this is the 4 resistance we can comparing by that, and form of it's in a bridge. This is the diagram. See, this is the taken by the four resistance P, Q, R, S. This is the P, Q, R, S of the four resistance. And then can be form of a four junctions. This is the four junctions are can be formed by there. And this is the A junction, and this is the B junction, and this is the C junction, and it is also considered the D junction. Now observing here the junction C and D between is connected by the galvanometer. The galvanometer can be measuring of a current. And the junction A and B, the junction A and B between we are connected by the battery of EMF E. EMF of E. And now the current can be, the current where is to can be passing by the positive terminal to negative terminal. Now this current I is when the reach at the A point. The reach at the A point, that is nothing but to A junction. The after that we can observing the A junction, it will be have the two ways. How many ways are it? Two ways. That current can be also dividing off this two ways. Now this direction of the current is we are considering by the I1. This direction of the current, how much is considering by the I2. See, when the current I can be reached at the junction A, after that it have the two ways. That's why the I current can be divided into two ways, I1 and I2. This I1 is crosses the resistance and reach at the C point. Reach at the C point. Again, the crossing of the C junction. Again, how many ways are there? Two ways. Now, this is a Q resistance is passing through the I3, and the galvanometer of the passing of the current, how much is considered? Ig. Now, this Ig current is enter into the junction D, and the I2 current is also enter into the junction D. Again, here the I2 and Ig of the current can be combined. Where is the junction D? And this passing of the current is there here the I4. So this is the arrow mark. We can observe the here the most important, what is there here the arrow mark. The arrow mark is the toward the junction, that is the enter. And after that is there, that is called the leaving of the junction. Now this I4 is coming to the junction B, and here the I3 is coming to the junction P. And I3 and I4 the combined to the junction of the B, and after that the passing of the current of the I current. Now this is called this total construction is called the Wheatstone bridge. Now using of this Wheatstone bridge, now we can comparing of the four resistance P, Q, R of the resistance. The formula we can develop. Observing here the Wheatstone bridge that consists of four resistance P, Q, R, S are connected showing in figure to form the four junctions A, B, C, D. Between A and B, battery of EMF is connected. Between C and D, a galvanometer of resistance G is connected. At a junction A, the total current I, the divided into I1 and I2. At junction C, the current I1, the divides into I3 and Ig. At junction D, the current I2 and Ig combined as a form of I4. And using of these junctions, we can apply the Kirchhoff first law and Kirchhoff second law. Kirchhoff first law and Kirchhoff second law.